This video is on the objective perform and interpret a hypothesis test for the mean, population standard deviation unknown, right? So sigma is unknown. You're performing a t-test, not a z-test. And this is using technology or the calculator, right? So I'll be working with the TI-84 Plus that I have on my computer. You have a TI-83, 84, very similar. All right, and this is also the second video I'm doing on this, so if you want to go back and watch the first one, hopefully you have, and you can see where to find out how to do all the, do a one mean hypothesis test with sigma unknown, a t-test on your calculator. All right, so here's the next question that I'm going to look at related to this objective from your Newton Alta homework. Again, if you want to see how they're doing things, how they instruct you, click on more instruction. Look at their videos, their notes, their examples. Hopefully they help you out. Alright, so here the owner of a shoe store wanted to determine whether the average customer bought more than $100 worth of shoes. So she randomly selected 10 receipts and identified the total spent by each customer. The totals, rounded to the nearest dollar, are given below. So we're given, one receipt. The customer spent $125. Another customer spent $99. Another customer spent $219, etc. So they're asking us to use a calculator to test whether the mean is greater than $100, and then draw a conclusion in the context of the problem using a significance level alpha of 5%. Okay, so again, usually, like I do with most tests, you're going to go through the steps here. The claim that we're testing, is that and I'll say mu here, I'm not going to write it out this time, but the mu is the average amount spent by customers at this shoe store, all customers, the whole population. And we're testing whether the mean is greater than $100. Right, so the claim here is that the average amount spent by customers at this shoe store is over $100 per person. So then your hypotheses, right, the null hypothesis, the alternative hypothesis. This would be the alternative hypothesis, that the mean is greater than 100. The null hypothesis, you could write that the mean is less than or equal to 100, but again, you've seen this many times now. We're going to be assuming just the equal part. So we're going to use that, as the null hypothesis. We're going to assume that the average customer at this store spends $100. Right? The average spent per customer is $100. We're given that alpha is 0.05, right? We're told that the significance level 5%. Then you take a sample, and the idea there's more steps. But I'm just going to put this up. Now, they're asking us to, we're given the sample. Now you can go and you could find the average, what's x bar by hand, find the standard deviation by hand, the S, then find your test statistic, the t-score for that particular x bar. And that would take a while. I mean, it's not impossible, but it would take a while. So that's what we're going to the calculator for. All right, so what I'm going to do is I'm going to enter my list of data in the calculator. Go stat, edit, and I've got list 1 cleared. It doesn't matter which one, just make sure you're paying attention to which list you're entering down. So 125, 99, oops. All right, so I'm going to actually come back when this is complete. All right, so I'm done. I've entered all 10 values and double checked to make sure I typed everything in correctly. All right, down list 1. So now I get out of here, and I'm going to perform this t-test, right? This test for one population mean where sigma is unknown. So it's the same place as with a z-test, or just like you saw in the first video on this objective. I go over, hit stat, go over to tests, and then number 2, right? T-test. And we have a list of data. Now, if you want, you can go to stats, but we don't know the sample mean, we don't know the sample standard deviation, so that's why I'm not going to use that part. But if we were given the sample mean and sample standard deviation, I'd use that. So I'm going to go to data. Now, what is this mu 0? Again, mu 0 is what you're assuming the mean is from the null hypothesis. So back on my paper, right, that was 100. Right, so this mu 0 is 100. Right, what we're assuming the mean is from the null hypothesis. And then you have your list of data. That was again down list 1, L1. If you have it down some other list, just hit second and one of these numbers here, right, L1 through L6. Just pay attention to what list you had the data down. The frequency list should just be 1. There is no frequency list here. There's no probability list. Everything is counted one time in this sample. So just leave that as 1. And finally, the last line before calculating is, what does the alternative hypothesis look like? What kind of a test do I have? Now this is mu is greater than 100 is what we're testing. So mu is greater than mu 0. I go to that one, a right-tailed test. And then hit calculate, and it shows you the alternative hypothesis, gives you the test statistic, right? That's what this t-score is, the test statistic. But the most important thing is this p line. P equals 0.1738. That's the p-value of the test statistic. That's the p-value. And then you have the sample mean, the sample standard deviation, the size of the sample. Okay, fine. But the p-value, the third line down, is the most important one. Because you're going to compare the p-value. So again here, the p-value is approximately 0.1, I'll say 1739. And compare this to alpha. And you can see that the p-value is definitely greater than alpha. 17% compared to 5%. And remember, if that's the case, if the p-value is greater than alpha, you do not reject the null hypothesis. You fail to reject it. If the p-value is less than or equal to alpha, that's when you reject the null hypothesis. So we are going to fail to reject. We do not reject the null hypothesis. Right? So that means we're keeping this. Right? We're keeping this and rejecting this. Right? And that was the claim. So that means we're not supporting the claim. Right? Well, that means our evidence does not. This particular sample of evidence, this sample of data, does not support this statement that the mean is greater than 100. Right? And that's what we'll conclude. So back here, right, so again, we're not rejecting the null hypothesis because the p-value is greater than alpha. And let's see, there is sufficient evidence to conclude that the mean is greater than 100? No. I just said we're not supporting it. This is saying there is enough evidence to say that the mean is greater than 100. That was the alternative hypothesis. It's this statement then. Fail to reject the null. There is not enough evidence, right? Insufficient evidence to conclude that the mean is greater than 100. Wonderful. Again, based on this sample of data that we were given. And again, read through your answer explanations, please. Alright, so hopefully watching me do this or looking at more instruction, hopefully all that stuff helps you out when you're working on this stuff on your own. And thank you for watching.